This is lesson 2.4, visual summary. So we have a table here that describes the time driven and the distance traveled. And I'm going to use T for time and I'm going to use D for distance. So we want to complete the table using the rate Jimmy was driving. So the only place in the table where I have two values is right here. And remember, I'm going to write my constant always as, this is my X column in my table. This is the Y column. Constant, K, is always Y over X. So I'm writing 60 over 1 is my constant here. So let's try to figure out first, well, if I have driven 0 time, then my distance is going to be 0. So I know that this graph, if I'm going to look at it, would look like it starts at the origin. Then after 1 hour, I drove 60 minutes. They first want us to determine the time it takes Jimmy to travel 480 miles. So I'm going to use this constant, 60 over 1, and that's equal to 60 is the distance, D, 1 is my time. So now I'm going to substitute the 480 miles. Miles is distance, so it goes right here. So now I have the ratio 61. Now I'm setting up a proportion. In place of D, I'm going to put the 480 miles. And I have my T. So we want to solve for T. I'm going to use means and extremes, even though in this case we can scale up. You won't always be able to scale up, so I want you to get used to using means and extremes. So 1 times 480 is 480 equals 60 times T. I need to isolate for T, divide both sides by 60, and I get T equals 8. So I can come back up into the T column of my table. It would mean that if we went 480 miles, it would have taken us 8 hours. Okay, now they want us to determine the distance Jimmy drives in 3 hours. So we're going to be getting this answer here. So I'm going to go back to my constant, 60 over 1, and that is equal to the distance over the time. Now I'm going to put this 3 hours into the time. So 60 over 1 equals D over 3. Now I'm going to use my means and extremes. 1 times D is D. 60 times 3. So when I solve, D equals 60 times 3 is 180. And that stands for miles. So my answer would be 180 miles he would have driven in 3 hours. So we want to know, is this relationship between time and distance an example of a direct proportion? Remember, that could also say direct variation, could say varies directly. So we need 2 things to happen here. It needs to be straight, and remember, it needs to be through the origin. So I already see that this relationship would be through the origin. I want to just verify that it's going to be straight. If it's straight, I get a constant every time. So if I took 180 over 3, I get 60. If I take 300 over the 5, y over x, I get 60. If I take 480 over 8, I get 60. 60 over 1 is 60. So it will be straight because I have a constant and it does run through the origin. So yes, it is direct proportion because the graph would be straight and I'm going to say that is also because we have a constant and the graph runs through the origin. So what is the constant? Remember, constant's a lowercase k. It's always y over x. So I had to make sure that it happened in every situation. I can't just do it once and assume. But because I got 60 every time, what is the constant? My constant is 60. Now we want to know, what does that constant represent in this situation? So I'm going to write that constant as a fraction. And again, I'm going to put some labels on there, because this 60 stood for my miles, because remember, constant is y over x. So y over x, y was 60, x is 1. I'm going to put labels on these. 60 is miles, the 1 is hours. So I have 60 miles. So what does my constant represent in this situation? It represents that Jim traveled 60 miles per hour. That's the constant. It's the constant speed that he maintained. Now they want me to write an equation representing the relationship between the time driven and the distance traveled. Let D represent distance and T represent time. So again, going back to the constant, 60 over 1. 60 was the distance, 1 is the time. I'm going to solve this. So I'm going to say means and extremes. 1D, which is D, equals 60T. Here is my equation. So that tells me that every time, every hour that I travel, if I multiply it by 60, I would get the distance that I traveled. So I came up with an equation. I could go back and use my equation to solve these. Let's take a look at that. D equals 60T. If I went up here, and now this 480 is a distance. So if I put 480 in place of D, now if I solve for T, I need to divide both sides by 60. And I get 8 equals T, and we said that's hours. If I use my equation again here, D equals 60T. Here time is 3 hours, so in place of T I'm going to put 3. D equals 60 times 3. D equals 180. That's what we ended up with. So we can write ratios to solve. We can come up with an equation, use our equation to solve. And from chapter 1, we can solve with proportions.